Welcome. Thank you. So I want to talk about CUPID. CUPID is a backronym, which means it's an acronym where I started with the word and then made up the things to fit the letters. Okay, this is deliberate. What it also means is there were many candidates for each of the letters. Okay, so this is about the ones that won. So let's start. In around 2017, which is 8 years ago, that's a really long time ago, I was at an event called PubConf. It's actually a conference called NDC. And NDC originally is a .NET conference. Now it's a bit more broad. And this NDC conference, they have a thing afterwards called PubConf, which is a genius idea. And the idea is that PubConf grabs a load of the speakers from the NDC conference and takes them to a pub, and those speakers do a 5-minute talk and 15 seconds per slide, you know, that kind of thing. And then people rate the talks, and basically everyone has loads of beer. Okay. And what happens at PubConf stays at PubConf. There are no recordings. Okay. And so they asked me to do a talk, and I was like, right, I've got 5 minutes to do a talk. I know I'm going to have a go at Solid because there's 5 things in Solid. So this talk's going to write itself. I have, for each slide, I have introduced the thing, why I think the thing is bad, and what I want to do instead. That's 3. Times 5 is 15. Top and tail it. That's my whole deck. Okay, so I did that, and they came after me. They came after me with pitchforks. They told me I was wrong, and then I had to, and it wasn't good. Anyway, that was just a fun 5-minute thing. Oh no, I'll tell you what I did. I put the slides up online. And that's when they came for me, okay? So there's a thing called Extreme Tuesday Club, XTC. It's been running in London for 20-something years. It's one of the oldest extreme programming meetups in the world, I think. It's been going for a long time, and around about, I don't know, 2 or 3 years later, one of the organizers contacted me. They said, look, we're doing a thing about Solid. We'd like you to kind of present, you know, talk about stuff because you did that thing at PubConf. And I was like, okay. And the challenge he gave me was brilliant. The challenge was, okay, if you don't like Solid, what would you do instead? And it was February. So it was kind of near Valentine's Day. And I thought, I'm going to go with CUPID, right? Because it's like the opposite of macho software craftsman, like CUPID. So now I had a challenge. And then, of course, I just procrastinated. And then I'm really bad at my own timetable, but like doing my own stuff. I'm 12 years into writing a book now. I started writing a book in, people nodding, yeah, we're waiting for the next chapters. Right, so exclusive. What I've done is I've taken a 40 chapter project, which is overwhelming, and I'm breaking it into small pieces. And the first small piece is Patterns of Effective Teams, and that book is nearly done. Whoa! And then I'm going to basically pull out the whole of Software Faster into small books. Anyone who's ever bought Software Faster off LeanPub, you will get those books for free. Okay, I'll be doing a thing, don't worry. But I'm really good at other people's deadlines. So if I'm speaking at Craft, I've got to get a talk, right? So they said, right, we need to put a talk together. So I thought, okay, I probably ought to do something. So before we get into CUPID then, I want to set the scene. Let's start by asking this. Who are we writing code for? Okay, who are we writing code for? These days, robots, okay? Our robot overlords. But it starts with, for me, it started in 1996. I'm old, okay? In 1996, I read Refactoring by Martin Fowler, which is a book of patterns of refactoring, of deterministic refactorings of software, extracting a method, renaming a variable, pulling up a parameter. And all of these things, there was this really crazy thing that happened, like very, very rapid sequence of events. Martin publishes this in Refactoring in 1996. By 2000, there was an IDE called IntelliJ, JetBrains, that could do them all. So they'd gone from being descriptions in a book to actual deterministic things you could do. Anyway, this statement appears at the beginning of Refactoring. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. And I was like, I am enlightened. And then I looked at it and I was like, can we do better than understand? Understand seems a bit of a low bar, right? And then A while later, I came across this wonderful, wonderful essay by Dick Gabriel. Kevlin Henney got me onto this. Kevlin Henney gets me onto lots of things. If you want to have your mind blown, go and look at Kevlin Henney talk. He's very good. But he talks about, so there's a whole series of papers called Patterns of Software, and this one's called Habitability and Piecemeal Growth. And in it, he says this: habitability is the characteristic of source code that enables, and he has a whole bunch of different kinds of people, to understand its construction and intentions and to change it comfortably and confidently. I was like, I quite like comfortably and confidently. That sounds like a thing I want. He says habitability makes a place livable, like home. I'm like, habitable sounds better. What about joyful? What about joyful? What about, okay, who here is a programmer? Who writes software? Practically everyone. Who doesn't write software? You're a cause of software and other people, aren't you? Yeah, they're managers, right? So all of you, I want you to think about when you've been, some of you may not have experienced this, when you've been in a code base that's just made you smile. I remember this, I'm in my 50s now, I'm ancient, right? When I was about 21 or 22, one of my first jobs, there was this huge, complicated, it was an digital image processing code base, hundreds of thousands, possibly millions of lines of C code. I don't know, it was vast. And what it would do is it would take CMYK images, so cyan, magenta, yellow, black, so images for printing onto paper, 4-color printing, and it would do color correction of these images. And basically, color correction is a 4-dimensional hypercube for each of the colors, CMYK, and along that you have as many colors as you have, say 256 or something, which doesn't sound that many now, but back in the early 90s, believe me, that was an awful lot of computing. And you would have this 4-dimensional hypercube of 256 or 10,000 or whatever colors. And it would basically be a massive matrix calculation. You put a color in and it would have to be 4 dimensions and you get a color out. And you did this big lookup. And anyway, there was a bug. There was a bug in this that sometimes bits came out pink. Okay? And I'm the rookie, Dan, go solve the bug. Go find out why it's sometimes pink. And I was like, this is like, your imposter syndrome is real. This is where they realize I have no idea what I'm doing. So I go into the code base and I look in the code base and I'm like, wait, I understand this. This makes sense, right? And then I started navigating it and it was very easy to navigate. I was using an editor called VI and it had a thing in it called C tags. And C tags was the thing that meant you could navigate from function call to function reference, function definition and stuff. Anyway, I navigated around the code, found the bug. It took me about 10 minutes to find the bug. It was a very easy bug to find. And it was one of these like less than instead of less than equal or something like a range error thing. And I fixed it. I changed the code and I rebuilt it. No tests, right? These were wild times. But then, I built the thing and I ran a few test images through it. No pink dots. And also no other really strange. And I remember just going, right? And what I was going yes about wasn't my ability to code. It was whoever had gone before me, they left it in a way that even I could find it. Okay, that's what I'm talking about. So can we describe what makes that code make you smile? Was my kind of exam question to myself. And then what kind of properties would joyful code have? A code base that just brings you joy. And before we get into those properties, I want to get a bit meta. And I want to talk about why properties rather than principles. So solid, the acronym solid. Who's come across solid? Who's not come across solid? Don't be afraid, that's fine. Okay, so solid is a set of 5 principles. There actually is the first 5 of 100, more than 100 principles that a guy called Robert Martin put together in the Middle Ages. And one of the guys working with him noticed that the first 5 of these, if you change the order slightly, went SOLID. And they called them solids. There's 5 things. Single responsibility, open, close, list cost substitutability, interface segregation, and dependency inversion. Yes, right. I'm amazed that I got all those 5 right. So I think most of those are complete nonsense, and that was what my original talk was about. And they went, oh, you can't say that. This is written in stone. And so I prefer properties. And here's why. Principles are guidelines. They're rules, right? They set a boundary. They create what's called, they create what's called a bounded community. You're either right or you're wrong. And so you get solid police going around saying, oh, that violates single responsibility. And well, I'm not sure about substitutability. And stuff, right? And then we do code reviews. Like, oh, look at that's not very open and closed. I don't even know what they mean, right? Like, there's no anyway. I'm not going to do that talk now. But the point is, with principles, you're either in or you're out. Okay. Properties are more about having a center, what's called a centered community. So these are about a goal or a center that you can be further from or nearer to, but there's no outside. Right? And it also means you can always improve. Yeah, wherever you are, you can move further towards that center, okay? And so you can choose, then you can make trade-offs and decide how close you want to be to these various centers. And so I'm going to get a bit meta now. What properties would properties have that were useful for describing joyful software? Are you still with me? Brilliant, okay. So the first thing is they need to be practical. I'm not academic. Okay, I've been academic, I'm not academic. I hang out with academics, they're lovely people, but I wouldn't want it, I couldn't eat a whole one. But so it needs to be something where you can use it. So it's easy to articulate. I can describe it to you in an elevator, right? You can look at your code and say, to what degree is this that thing? And you can also decide, I fancy trying that thing over here, okay? Those three things need to be true. It needs to be human. Remember, this is all about people and joy, right? This is visceral. It's in your stomach, okay? So I want to describe code from the perspective of people reading code and navigating code. I'm writing to 21-year-old me and saying, don't worry, Daniel, it's going to be fine. It's going to be okay. As well as people writing code. And a lot of the stuff I see around principles are about how to write good code, not how to write code that is then easy to make sense of later. And the last part is I want nuance, I want layering. So it's not the world isn't black and white, okay? Properties like this aren't black and white. There's I can describe it in one sentence version of these things. Then there's but what about, more nuanced? And then there's the people who've been around the block a bunch of times saying, well, actually, there's a whole load of nuance to this. And I love those conversations. So, ta-da, CUPID, the reveal, right? And so this is where I ended up. I ended up with 5 things. The first thing is that I want code that's composable. Right? Composable means it plays well with others. I have little chunks of code and they play nice with other chunks of code. The second thing is about Unix, like Unix philosophy. The Unix philosophy is you have lots and lots of little commands that do one thing well. Okay, that's it. They do one thing well. They do only one thing and they do that thing well. And again, I'm going to expand on all of this. The third thing is I want code that is boring. I like boring code, okay? I want predictable code. I want code that when I run it, it does exactly what it did last time. It doesn't lie, and then when I ask it if it lied, it then lies about lying. Or it says, oh, that was very clever of you to spot that I was lying. Does anyone know what I'm referring to? Don't worry. Idiomatic. I want code that makes sense to someone who knows that kind of code. I am someone who has written Java in Python, right? I have tried to bend Ruby to my will as a C#. These things you can, but it's not healthy, yeah? And finally, domain-based. So I want to be thinking in the language of the domain, all those kind of things. So let me unpack each of these, okay? Composable. What do I mean by composable? Here's a handy guide, so you can see where we are in the acronym. Do you like that? That's for you. I did that for you. Okay. Code that's easy to use gets used, and it gets reused, and it gets used again, right? We like code that's easy to use. Code that's easy to use gets used, okay? If you make your code inaccessible, if you make your code hostile, people won't use it. And not only will they not use it, they'll write something that's just like it. So I've seen especially what I call adjacent code. So this is a pattern that you see again and again, particularly in large organizations, is I want to go and change the image calculation code. Let's stay with images. I want to change the image calculation code, but what's your name? Amos owns that code, and he's horrible. He's not. He's lovely. I need you to know he's lovely. But in my story, basically we're scared of him. He's very senior. He doesn't, like this. And so I could go to him and ask him to make a change, but he's busy and he's important and stuff. Sorry, I'm being really mean. And so I don't. What do I do instead? Instead, what I do is I make my change adjacent to his code. The code change should be in his code, but I'm going to make it adjacent. But the thing is, there's more than one of me. There's me, and there's this me, and there's it. So, and very, very quickly, we end up with a dozen different implementations of something that should exist inside that piece of code. But the code, or the team around the code, or the whatever, the testability of the code, something about that code means I don't want to touch it. And so I'll make adjacent changes. And this is where we end up with lots and lots of similar but different and slightly buggy variants of a thing. Okay? Code that's easy to use gets used. I like code with a small surface area. I like code that does a little thing. Less to learn, less to go wrong, and less to conflict with other stuff. Okay? I was writing something once. It was back in the days. Has anyone here ever heard of an enterprise Java bean? That's one of those. That's one of those. What do they call it? Like a test. Basically, that's me saying, put your hands up if you're over 45. Okay. A shibboleth. That's the word I'm looking for. A shibboleth is like a code word that means you know some particular thing. So EJBs were notoriously horrible coding idea that came out of Sun Microsystems and IBM and Oracle in the late 90s. And I wrote a little open source. My first open source contribution was a little testing framework that meant you could test EJBs without having all of the stuff that goes with them, right? And I had this testing framework, and it used a thing called log4j, which some of you will have seen in the news not so long ago, for not good reasons. Anyway, log4j was the de facto logging framework in Java, and my thing used log4j. And so I published my open source project, and my buddy said to me, he said, why have you got that logging in there? I said, well, it needs logging. He said, right, I can't use your thing. What do you mean? Well, I want to use your lovely, lovely testing framework, but I'm using a different logging framework, and it's not compatible with log4j that you've made it my problem. Or I'm using a different version of log4j than the one that you ship with, which you've made that my problem. Yeah, either you're ahead of me or behind me, but basically it's a problem. And immediately, because of this totally innocuous looking dependency, I'm now blocking a whole load of people from being able to use this thing. Okay? Smallest amount of surface area. Give things intention revealing names. I did this, again, back in the enterprise Java days. I was writing, if anyone's ever connected to a relational database using Java, there's about 15 different interfaces that you go through. Anyway, I won't tell you what they are, but they're quite boring, and there's lots of them. And I was about to write a utility class that was going to do all of that plumbing for me. And so I gave it a name, like, JDBC query preparator. I came up with a pretty cool name. And I wrote the name, class, whatever. And then IntelliJ popped up and it said, do you mean? And there was another class with exactly the same name deep in a library somewhere. I was like, I don't know, do I? And I clicked, and it was exactly the code I was about to write. Okay, and I just went, yes, thank you, universe, thank you, God. And this is what I call serendipitous naming. Okay, so what happened was, because the people who designed that API used the same language that everyone else uses, I coincidentally came across that thing that was buried in an API somewhere. Saved myself a day's work and a load of testing and having to maintain a thing that I didn't want to maintain. Yeah. So make it things easy to discover and minimize the dependencies. The late brilliant Joe Armstrong, one of the guy that designed the Erlang programming language and the OTP, which is basically every microservices, every observability platform in the last 20 years is a bad implementation of Erlang. Okay. Erlang gets it right. Joe Armstrong, this is him talking about object-oriented languages. This is, you want a banana and you get the whole gorilla. This is except with Java, where you want a banana and you get the whole jungle. So when we minimize dependencies, we make it easier to consume those things. So composability isn't just about API and interface. It's about what happens under behind the shell as well. Hey, Unix philosophy. What does this mean? It means do one thing well, right? Make each program do something well. LS. Who's on a Linux, Unix, Mac command line from time to time in the room here? I imagine most of you, right? Who's typed ls at a prompt in their life? Right. What does the ls command do? It lists files, right? How does it know what to list? How does it get that information? Anyone know? No. No, because that would be coupling. That would be too many things. ls is not a file lister. It's a file information formatter. That's what ls does. The thing that gets the file information is a thing called stat. There's a system call called stat, and you give stat, you tell stat to give you the contents of a directory or the details of a file, and stat comes back. And what ls does is it calls stat on a bunch of things, and then it formats the output. Okay? So ls doesn't even know about file systems. Who learned a thing tonight? There we go. That's what I mean about doing one thing well. ls is brilliant at tabular representation of file information. That's all it does. Right? Stat is brilliant at finding information, but it knows nothing about how to format it, how to present it. And so now you have this idea of composability, things that can connect to each other, and doing one thing well. And so Unix was one of the first OSs to put the idea of a pipe front and center, chaining commands together. And so the Unix philosophy says this: everything in Unix is a file. Memory is a file, files are files, the network's a file, block devices are files, a tape. Anyone remember tapes? Tapes are files. Everything's a file, right? Images are file, anything's a file. And a file contains text or not text. And every single program has 3 file descriptors, has an input, and an output, and an error output. You can have more, but that's your table stakes. And then if you want to do processing, you can chain together the output of one is the input of another, the output, and you've got just Lego bricks. Clonk, 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 clonk. So I can go cat gives me the contents of something, grep filters it, sed transforms it, sort sorts all the results out, unique removes any duplicates, and so on, right? I can get very sophisticated text processing pipelines just from simple commands that do one thing, yeah? Why is that not single responsibility? What's Unix philosophy? Do one thing and single responsibility. They sound like the same thing, right? Yes? No? Okay. They're not. Don't take my word for it. They're not. So SRP is about how the code changes. Okay. So for instance, the canonical example is a report. You have the view of a report, you have the data in a report, and you have the processing, the calculations. And the idea is that each of those are going to change independently, so they should live in different places. Unix philosophy says, no, they should all exist in the one place, but your big report should be made up of lots and lots of small reports with batteries included, right? So the code looks different. Their code, SRP code, has the views over here, the models over here, controllers over here, whatever it is over here. My world, my little composable lumps that do one thing, have a model view controller, whatever it is, if that's your, in that web world. Each of those things are a single semantic lump because they probably do change together. Because if anything on the report changes, I probably do need to change data, and I probably do need to change a calculation. And unless it's literally changed the shade of blue, right? I'm likely to need to touch all the things, and now they're all in different places. Predictable, I need to speed up. Predictable means it does what I think it's going to do with no surprises. So Kent Beck talks about it passes all the tests. And I'm generalizing that and saying, what if there's no test? Okay? I was in a team that built a complex high-frequency trading stack. This thing was shifting millions, possibly tens of millions of dollars worth of trades a day. At its peak, and I measured the test coverage on it at one point. And what was the test coverage on the code base that was doing business critical financial calculations that if it went wrong was going to cost a lot of money? Percentage test coverage? 40? 60? Wow, you guys are amateurs. What? 0.5. High, no. 7%. But here's the thing, it was a very unevenly distributed 7%, right? A lot of it didn't have tests because the code was so obvious it couldn't not do the thing it needed to do, right? And some bits of the code had insane amounts of testing. Like we invented different kinds of testing for some of it, yeah? So it's about proportionality, okay? I want it to do the same thing every time. I want it to be deterministic. I want to understand its memory usage, its CPU usage, when it spikes, how it fails, all of those things. And I want it to be observable in the classical sense, i.e., I can determine everything about what's going on inside purely from signals coming out. This is from signal theory, right? Control theory. So I need instrumentation, I need telemetry in there. That's not a thing you bolt on afterward. That's a primary design consideration. Idiomatic is an interesting one, right? Idiomatic is arguably very subjective. I want you to use language idioms. If you're writing C#, I want you to write C# like all the other kids. If you're writing, well, Scala's an interesting one. Some languages have very clear idiomatic style, okay? Clojure is a Lisp. Lisp has there's a Lisp style. Lisp is very minimal. It's like the idea with Lisp is a language building language. So you build the atoms you want for your language, and then you build your program using your language you just built. Go, the Go programming language, ships with a thing called Go format, which means all code looks the same. Do you know all code is tab indented? That's illegal in a lot of states in the US, right? I don't know, there's a whole bunch of things that are basically, I'm sure that the team that came up with the formatting guidelines said, we're going to offend everybody, right? And when you have multiple assignments, right, it lines up all the equalses. Oh, that makes me so happy. Anyway, what it means is no one ever discusses Go code syntax, right? Because it all looks the same. If you look in the standard library, if you look in blog posts, if you look in internal code, it all looks the same. It looks like Go code, yeah? Even the naming of things is really obvious, okay? So some languages guide you in that way. Some languages say you're on your own. Scala is the least opinionated language I've ever found, which means that in any code base, in any Scala code base, you will have 7 different styles, possibly in the same file, right? Which means that you have to have really strong opinions. You need to have local idioms, local, a house style, and those house coding design standards might not exist, right? You might need to make them up yourself. And so it's important when you work in a new language or a new stack or a new code base is to take the time to understand what's going on. You can only write idiomatic code if you take the time to learn the idiom, okay? If you don't learn the idioms, you cannot write idiomatic code. You will write idiomatic code, but from a different language, from a different stack, from a different whatever. And then don't write for you now. Write for future you who's already learned Go, or future you who's already learned Rust, okay? So when I mean idiomatic, I don't mean easy for you to understand now. I mean easy for an experienced Rust programmer to look at, okay? And finally, domain-based. So what do I mean by domain-based? There's 2 parts to this. Partly is using the domain language. I've got an entry in 97 Things Every Programmer Should Know called Code in the Language of the Domain. And it starts with a very cryptic line of code that says like, if int something is in map of ints to a map of ints to ints, okay? And loads of angle brackets because it's Java and it's all generics. And it turns out that you can refactor that into a very simple, very intention revealing line of code. Yeah. Code in the language of the domain. Make it so that if you're talking about the code or talking about the problem the code solves, you're using the same words. I shouldn't be able to tell which of those 2 things you're talking about. Yeah. But the other part, which is more subtle and I think much more important, is using domain structure. So again, if I go into something like Rails, and I do Rails new blah, it vomits out 60 plus files into 50 plus directories, all nested and stuff, yeah, which is immediately my problem, right? But also, at the top level, it's like models, views, controllers, blah. I've got no idea what that code does, okay? So instead, I want to structure my code based on the solution, on the problem it's solving. I don't want models, views, controllers. I want payment, loans, onboarding, customer complaints, whatever. I want the top level to be the core business domains. Within those, I want to understand the different use cases, should be in their own packages. And in there, I will have model, view, controller code, maybe even in separate files, depending on your language and whatever. But all that code is together. And there's HTMX. I don't know who's come across HTMX. Very, very wonderful, lightweight web how it should be done. The guy behind that came up with this lovely acronym, locality of behavior. So instead of single responsibility and having everything spread apart, he says everything that's involved in some behavior should sit together. So he says locality of behavior. So you should have your SQL embedded in your PHP code, embedded in your whatever. If all of that together is doing a customer query and putting it on a screen, it makes sense that all that code is in the same place. In the olden days, someone would have done data, someone else would have done the view, someone else would have done the processing, but we don't do that anymore. Right? Back in the 90s, when all of this stuff was being described, these are separate teams. They might even be separate companies, right? Now we have the same people all sitting together. The same person might be doing the coding, the SQL query, because she's really good. She's full stack. She even designs CPUs. No, she doesn't design CPUs. Not quite that full stack. But generally, we are much more into what we call generalizing specialists. Okay. And then we use domain boundaries as well. So we think about what are the bounded contexts and domain-driven design terms and so on. So there's CUPID. Very briefly then, because I'm already out of time, I want to talk about what happened next. So I started talking about this, and then people started contacting me and saying, I'm using CUPID as a way of assessing a code base. I'm looking at the code and I'm saying, how composable is this? How Unix-like is this? Where can I draw obvious boundaries around behavior, or is the behavior smeared all over the place? And if it is smeared all over the place, what work do I need to do to bring it together, right? Someone said they were doing a thing called a code critique, which is like a code review, but it's more about I want to learn about the code rather than beat people up, right? I'm taking on a big, scary legacy code base. I don't know where to start. I'm going to use CUPID as a way to think about, a way to articulate that, have that conversation. Someone said they were using it as a syllabus for a programming course, which I got really excited about. So they're at a college and they're doing a programming course and they're using CUPID to talk about how to write good code. Yay! So about a year afterwards, sadly, it's on the 15th. This is the day after Valentine's Day. It ends up on the front page of Hacker News, which really, really does wonders for your web stats. Okay. So this is a thing called Fathom Analytics. Anyone who's trying to get off Google Analytics, Fathom is brilliant. And so, yeah, 110,000 visitors that day. And then, boom, cricket slip. Ended up as a blip on the ThoughtWorks radar, which was fun. And then what I did is I took this huge article that I wrote, which is basically this talk, and I broke it out into a website called cupid.dev. So take a look at that. It's a nice thing to point to and link to. There's lots of permalinks there that are never going to change or never going to disappear. And there's a Google group. Cupid Joyful Code is a Google group. Sorry, a groups.io group, which is very, very quiet. It's like a little mill pond. Every couple of months, someone posts something. Everyone goes, oh, am I still a member? Oh, like that. So you're welcome to join that. It'd be lovely to see you there. And that's it. That's it. So share your stories. I want to hear about you trying CUPID, applying CUPID, critiquing CUPID. I want to hear why it's all wrong. That's how you get hold of me. I'm very easy to find. These slides, David, I'm sure we'll share with the meetup folks afterwards. That's pretty much all I had. So thank you.